Hello everyone, this is Dr. Raviraj Kulkarni, Professor of Chemistry, and I belong to one of the prestigious organizations in this part of Karnataka, that is KLS Gogte Institute of Technology, Belagavi. In this video, I'm going to share some tips to solve some CET, NEET, JEE questions on electrochemistry. I'll be discussing electrochemistry in two parts. This will be my first video on electrochemistry. Okay, let's begin. What is electrochemistry? Electrochemistry is the branch of chemistry which deals with the study of interconversion of chemical and electrical energy. So we will discuss some numericals on Nernst equation. What is Nernst equation? E cell is equal to E naught of cell minus 0.0591 divided by N into log Q. Q is reaction quotient here. N is the number of electrons involved in the cell. Standard cell potential E naught of cell. Cell potential is E cell. And 0.0591 is at 298 Kelvin. Faraday's laws. We'll be solving some numericals on Faraday's laws. Weight deposited or weight liberated is proportional to current into time. Remember, this is Faraday's first law. So that's equal to I into T into Z. That proportionality constant is called electrochemical equivalence. And Q, you know, I into T is Q. You can substitute for this I into T as Q, and Z, Q into Z gives the weight deposited. Faraday's second law talks about the ratio of weight deposited is equal to the ratio of their equivalent weights. W1 by W2 is equal to E1 by E2. Okay, that is equal to Z1Q divided by Z2Q is equal to E1 by E2. Okay, so we have one more equation here. Mass deposited is equal to E into I into T divided by F. E is equivalent weight, I is current, and T is time divided by F. Delta G is equal to minus NFE. That's another equation we will be using. At equilibrium, we know E cell is equal to what? E cell is 0. It becomes 0 at equilibrium. So Nernst equation becomes what? E naught of cell is equal to 0.0591 divided by N into log K. Here Q becomes K. Reaction quotient becomes equilibrium constant here at 298 Kelvin at equilibrium. Let's start with the first numerical. 1 liter solution of magnesium chloride is electrolyzed completely by passing a current of 1 ampere for 16 minutes and 5 seconds. 16 minutes and 5 seconds. The original concentration of magnesium chloride solution was, they have given the atomic mass of magnesium as 24. Option A, 0.5 into 10 raised to minus 3 mole. Option B, 1 into 10 raised to minus 3 m. Option C, 5 into 10 raised to minus 3 m. Option D, 5 into 10 raised to minus 2 m. Solution. So you remember this equation. What is mass deposited? That is equal to what? Equivalent weight into current into time divided by F. So equivalent weight of magnesium, we know it's magnesium plus 2. So this you have to divide it by what? 2. So it becomes what? 12. 12 into 1 into 965, that is 16 minutes and 5 seconds. Okay, if you convert into seconds, it is 965 divided by 96,500 coulomb. That's equal to 0.12 gram. So you calculated the weight deposited, the mass. Okay, but they want the original concentration of magnesium chloride. So you remember this when we discussed mole concept in the last video. Okay, we discussed mole concept. Okay, in that molarity equation we discussed. Okay, m is equal to what? Weight of substance into 1000 divided by molar mass into volume of solution. So here weight of substance is, we have calculated it as 0.12 gram into 1000 divided by molar mass, they have given as 24 into 1000. Okay, that's equal to 5 into 10 raised to minus 3. So equation the correct option is 5 into 10 raised to minus 3, option C. Okay, the original concentration of magnesium chloride is 5 into 10 raised to minus 3 m. Okay, option C is correct. Next question. An aqueous solution of copper sulfate is subjected to electrolysis using inert electrodes. The pH of the solution will, option A, decrease, option B, increase or decrease depending on the strength of the current, option C, increase, option D, remains unchanged. Read the question carefully. An aqueous solution of copper sulfate is subjected to electrolysis using inert electrodes. So when you use inert electrodes, what happens? So at anode, the metal will not go into solution. The water undergoes oxidation. The water gives 4H plus, 2H2O gives 4H plus plus, O2 plus 4 electrons. Electrons are liberated at anode. Okay, that's oxidation takes place at anode. So what is forming here? H plus ions are forming. Okay, if you are using inert electrodes, the pH of the solution will definitely decrease. Okay, you are adding more H plus ions. At cathode, what happens? The copper ions, they accept electrons, they become copper metal. Okay, formation of H plus ions at anode will decrease the pH. Okay, so option A is correct, decreases. So you should know why it decreases. So it decreases, pH decreases because of the formation of H plus ions. There is a reaction at anode. This is for inert electrodes, remember. We'll go to the next question. Question number 3. Given E naught of Mn plus 7 to Mn plus 2 is equal to 1.5 volt. E naught of Mn plus 4 to Mn plus 2 is 1.2 volt. Then E naught of Mn plus 7 to plus 4 is, read the question carefully, E naught of Mn plus 7 to plus 2, right? See this, right? It's 5 electron reduction, it is 1.5 volt. And Mn plus 4 to plus 2, it is 2 electron reduction, it is 1.2 volt. Okay, then E naught of Mn plus 4 to plus 7 to plus 4 is, option A 1.7 volt, B 2.1 volt, option C 0.3 volt, option D 0.1 volt. Solution. So you remember this equation, delta G naught is equal to minus NF E naught. So equation 1 you can write for Mn plus 7 to plus 2, that is 5 electron reduction. Mn plus 7 becomes Mn plus 2, accepting 5 electrons. Delta G naught becomes what? N is 5 here, and they have given E naught of Mn plus 7 to plus 2 is 1.5. So it becomes minus 7.5 F. Equation 2, they have given this Mn plus 4 to plus 2. Okay, 2 electron reduction. Delta G naught becomes what? Minus 2. That is 2 electron reduction, minus 2 into F into 1.2. That is equal to minus 2.4 F. Okay. So we want what is asked? Required E naught of Mn plus 7 to plus 4. If you subtract equation 2 from equation 1, plus Mn plus 7 minus Mn plus 4, okay, so it becomes Mn plus equation becomes like this. Equation 1 minus equation 2 gives you the required equation, that is Mn plus 7 accepting 3 electron becoming Mn plus 4. You write the delta G naught for this. Delta G naught is equal to what? N is minus 3, F as it is, okay, and E naught they have asked. Okay, they have asked E naught value. So minus these two, okay, minus 7.5 minus of minus becomes plus 2.4. F is equal to minus 3 into F into E naught. Right, E naught is equal to what then? E naught is equal to minus 7.5F plus 2.4F divided by 3F is equal to 1.7 volt. The answer is option A, 1.7 volt. This is correct. Next question. For a cell reaction involving 2 electron changes, E naught of cell is equal to 0.3 volt at 25 degrees Celsius. The cell equilibrium constant of the reaction is option A 10 raised to minus 10, B 3 into 10 raised to minus 2, option C 10, option D 10 raised to 10. Read the question carefully. For a cell reaction involving 2 electron changes, they are given N value, N as 2. Okay, E naught of cell they have given 0.3 volt and it is at 298 Kelvin, that is 25 degrees Celsius. Okay, solution. Okay, you can write this Nernst equation. Okay, anyway it's at equilibrium, so we know E cell becomes what? 0 and reaction quotient becomes K. Okay, equilibrium constant. So substitute that. Okay, 0.3 volt is the E naught of cell. Okay, so for approximation what I have taken 0.0591, I have taken it as 0.06. Okay, we can take that. Okay, 59 0.06 I have taken. N is 2. Okay, log K. Okay, we want log K, so log K becomes what? 10. So 0.3 by 0.03, so K becomes what? 10 raised to 10. Simple question, right? So you can easily score marks here. What do you have to remember? E naught of cell is equal to what? 0.0591. You write this 0.0591 divided by N into log K. Okay, at 298 Kelvin. That equation you should remember. I have already discussed, I listed this equation in the second slide itself. Okay, answer is option D, 10 raised to 10. Okay, hope you enjoyed my video. Please subscribe the channel, it is free. If you have any doubts, please feel free to contact me. My email ID is Dr. _Kulkarni _1976.